My name is Adam Conkey. I'm a PhD student at the University of Utah. I'm going to give a quick overview of my research in the area of representation learning for multisensory perception and planning. Robots performing manipulation tasks typically have a variety of sensory modalities available to them, including RGB and depth vision, joint state like joint position, velocity, and torque, end effector pose, object poses, and bounding boxes, say from an object tracker. We can compute instance and semantic segmentations of the scene. We also typically have force torque sensors at the wrist, tactile sensors of the fingers, maybe tactile skin, LiDAR sensors, microphones. We would like to take all the sensory information and integrate it in a useful way that the robot can perform tasks safely and reliably. This is typically done with deep neural networks, so you can take this multisensory observation, encode it down into this multisensory latent state, and then given a task like stack the blocks, we want to use all that information to perform the task successfully. This task actually has meaningful subgoals though, say stack one block on top of the other block. But if you look even at just one of these subgoals, it itself has subgoals like reach to the block, grasp the block, lift the block. And you can dig down even further to the low-level actions that the robot actually executes. So we would like our representation space to represent and reflect this hierarchical nature of the task and the data. So we can plan over these high-level states and generate meaningful subgoals that we can then use to produce the low-level actions that are actually executed on the robot. Some of the key challenges in this area are how these hierarchical representations can be learned in a self-supervised way. So we don't want humans to have to architect the entire task themselves. How are task level goals grounded to the representation space? So we also don't want to say, go to this image or reflect this image or go to this sensory observation. We want to have a logical or natural language abstraction that we can offer to the robot to specify these goals and that the robot itself can reason over at this higher level. Can these hierarchical representations support lifelong learning, right? So maybe initially the robot is going to perform simple tasks like reaching, grasping, lifting, but it can compose those tasks into more complex ones like picking and placing objects, opening and closing drawers. Putting an object in a drawer is then a more complex task that composes those skills. And then we can keep going so that eventually you can say, hey, robot, go clean my kitchen. And it will do that, knowing these different subtasks that it needs to perform. These high-level topics are the focus of my current and future research. Thank you for listening.